In this lesson, we're going to be discussing Surd. We're going to be focusing on components of Surd, rationalization, addition, subtraction, and multiplication of Surds. If you find this helpful, I want you to like this video, comment, and share with your friends. Also, don't forget to subscribe and turn on the post notification bell so that each time I post a new video, you'll be the first to watch it. So let's start with components of Surd. But before that, what is even Surd? What is Surd? Surd is the square root of any number that is not a perfect square. For example, square root of 3 is a surd, square root of 7 is a surd, square root of 11 is a surd, square root of 15 is a surd, and so on. Now, if you look at these 3, 7, 11, and 15, they are not perfect squares. But then, square root of 9, square root of 16, square root of 4, all of these are not surds because they are square roots of a perfect squares. Perfect squares are numbers gotten when you multiply a certain number by itself. For example, 9 is 3 square, 16 is 4 square, and 4 is 2 square. So root 9, root 16, and root 4 and other roots of a perfect squares are not a surd. So surd only refers to square roots of numbers that are not a perfect square. So let's discuss components of surds. So let's take a look at this root 3. So this root 3 is a surd, and it can also be referred to as a radical. So let's come to 2 root 7. Now this 2 root 7 is also a surd, but here 2 is referred to as the coefficient of the surd. So for this 4 plus root 5 is also a surd. Now 4 is the rational part of the surd. So this is a rational part of the surd. So notice that this 4 plus root 5 is referred to as a mixed surd because it contains rational parts and irrational parts. So 4 is the rational part. This root 5 is the irrational part or radical. Let's discuss rationalization. If you have 1 over root 3, now to rationalize this surd, we multiply both the numerator and denominator with root 3, so that 1 times root 3 is equals to root 3, and then root 3 times root 3 is equals to 3. Now this root 3 times root 3 is just root 3 raised to the power 2, that is root 3 square. If these two cancel this square root, you'll be left with only 3. So the concept of rationalization is to remove square roots from the denominator of a surd. So it helps for easier simplification, and it makes the whole calculations simple and also easy. So if you want to rationalize 1 over root 7, so just multiply the numerator with root 7, multiply the denominator with root 7. 1 times root 7 is root 7, then root 7 times root 7 is equals to 7. So if you have 1 over 2 plus root 3, so to rationalize this, we are going to take the conjugate of this denominator. So the conjugate is just multiplying the numerator and the denominator with 2 minus root 3. So change this positive sign to negative sign and then multiply everything by 8. So now 1 times 2 minus root 3 is equals to 2 minus root 3. Now this times this, we have 2 plus root 3 multiplied by 2 minus root 3. So 2 times 2 will give us 4. 2 times negative root 3 is negative 2 root 3. Root 3 times 2 is plus 2 root 3. Then plus times minus is minus. Root 3 times root 3 is 3. Now minus root 3 plus root 3 is 0. So we'll be left with 4 minus 3, which is equal to 1. So we have over 1. So as you can see, we have removed this surd from the denominator. So that is just the concept of rationalization, to remove surd from the denominator and make the whole thing easier to simplify. So if you have 1 over 2 minus root 7, to rationalize this, we just change this negative sign to positive sign and multiply both the numerator and denominator with it. So 1 times 2 plus root 7 is equals to 2 plus root 7. Then over 2 minus root 7 multiplied by 2 plus root 7 is just 2 times 2 will give you 4. Then minus, we take one of this radicand, which is 7. So which is 7. So generally, if you have a plus root b in the denominator that you want to rationalize, you are going to take the conjugate, which is equals to a minus root b. And if you multiply the original surd with its conjugate, you are going to get a square minus b. So just as what we did here, we get a square here, a is equals to 2, so 2 squares is equals to 4, then minus b here is 7, so 4 minus 7. So that's just the easiest way to do it. Let's discuss addition and subtraction of surds. So when should you add or subtract surds? If you have 2 root 2 plus 3 root 2, this is going to be equals to 2 plus 3 is equals to 5, then root 2. Just pick one of the root 2. So you add or subtract surds when the radicals are the same. So if the radicals are the same, you just add or subtract the coefficients as the case may be. For example, if you have 7 root 3 plus 4 root 3, since the radicals are the same, you just add these coefficients. 7 plus 4 is 11, then you have 11 root 3. So if you have 3 root 7 plus 4 root 5, so are you going to add this? Is it so if you have 2 root 7 plus 3 root 5, now can this surd be added? So the answer is no, because here the radical is root 7 and here the radical is root 5. So because they have different radicals, we can't add them. So it just simply equals to 2 root 7 plus 3 root 5. So the same thing is applicable to subtraction of surds. If you have 2 root 2 minus 3 root 2, because the radicals are the same, we just subtract the coefficients. So we are going to have 2 minus 3 is negative 1, then root 2. If you have 7 root 5 minus 2 root 5, so they have the same radicals, so we can go ahead and subtract them. So 7 minus 2 is equals to 5, then we have 5 root 5. So but can we perform this operation, 7 root 3 minus 3 root 5? So the answer is no, we can't subtract this surd because they have different radicals. So if they have different radicals, we just going to leave it like that. So this is still 7 root 3 minus 3 root 5. So in conclusion, for you to add and subtract surds, they must have the same radical. But if they don't have the same radical, you can combine them to form a single surd. So let's discuss multiplication of surds. If you have root 2 times root 3, so this can be combined as 2 times 3, which is equals to root 6. So it's only multiplication that, regardless of the radicals, whether they are the same or not, you can multiply them by combining them the way I just did now. So another one, root 7 times root 3 is equals to square root of 7 times 3, which is equals to square root of 21. So square root of 2 times square root of 5 is equals to square root of 2 times 5, which is equals to square root of 10. So let's multiply 1 over root 2 by 5. So 5 times 1 is 5, then we have over root 2. But it's not a day to leave square roots in the denominator. So let's rationalize this by multiplying both numerator and denominator by root 2. So it's going to be 5 root 2. That is 5 times root 2 is 5 root 2 over root 2 times root 2 is equals to 2. So 5 root 2 over 2 is equals to 5 over root 2. So let's multiply 3 over root 5 and root 6 over root 2. So 3 times root 6, this is equals to 3 root 6 over square root of 2 times 5 is 10. So we can't have surd at the denominator. So let's rationalize it by multiplying both numerator and denominator with root 10. So 3 root 6 times root 10, you have 3 root 6 times 10 is 60, then over root 10 times root 10 is equal to 10. So this is the answer to this. Thank you for watching. Please remember to subscribe to my YouTube channel, turn on the post notification bell so that each time I post a new video, you'll be the first to watch it.